Hi again. Ellie, say hi. Ellie. Oh, she's saying hi. You just can't see. Yeah, hi, sweetie. And there's Kai. Oh, he's smiling a little bit in his sleep. Okay. Hi again. We're going to look at some inverse functions. Oh, and there's Macy. Hi. Yeah, we're just kind of hanging out today on this cold day. We're gonna do some inverse functions. Girls, leave it. We're gonna do some inverse functions today. Uh-oh, I might not be able to do this right now. So we're looking at this worksheet right here. Graphing and writing the inverse of cube root and cubic functions. Guys, the second semester of Algebra 2 is basically the first semester of Algebra 2, but with different functions. So finding the inverse of a function is going to be just like finding the inverse of a function last semester. So let's look at some notes and things you need to know, but you actually already know. First of all, the inverse of a cube root function is a cubic function. All right. The inverse notation has that little -1, so you may not see the word inverse. It might just have that -1 symbol. Inverses are reflected over the line. Wonder if anybody remembers it. Y equals x. Remember, that's the linear parent function. And another way to identify or find an inverse are when the x and y values switch. Make sure you box that, because that's, to me, I think an easier way to test for or look for an inverse. Just find your x and y values and then switch them. Okay, and we're gonna look at finding the inverse of functions algebraically and graphically. Okay, so to find the inverse function algebraically, same thing as we did last semester. You're always gonna make sure you label everything with x and y. So change your f of x to a y. You're gonna switch the places of x and y. You're gonna solve for y, and you'll put it in that inverse notation. All right, so we're gonna start by, we're gonna do numbers 3 and 4, okay? So for number 1, they have this note that says if f of x equals this, 3 times x minus 1 to the power of 3 minus 5, what is f -1 of x, or f inverse of x? So this tells us that we're looking for the inverse. And since it's an equation, we're gonna look at those steps up here. All right, so the first thing we're gonna do is make sure we change this f of x to y. And then we're gonna switch the places of x and y. So now we're gonna rewrite this equation, but instead of it saying y equals yada, 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 it's gonna be x equals. So we're gonna have x equals 3 times y minus 1 to the power of 3 minus 5. Okay, so that's that very first step. Now, we're gonna be solving for y. So we have to use those inverse operations. Oh, isn't that ironic? Use inverse operations to find the inverse. So the first thing we'll do is try to isolate this grouping symbol. So we will add 5 to each side. So we're gonna have x plus 5 equals 3 times y minus 1 to the power of 3, and those 5s should have canceled out. Okay, now we would need to get rid of this 3, so we'll divide both sides by 3. So I'm going to divide this entire side by 3 over here as well. Those 3's are going to cancel out. Over here, there's nothing that we can actually divide by 3, so you're going to leave it like this. So we'll have x plus 5 divided by 3 equals y minus 1 to the power of 3. Now we can undo the cube by taking the cube root of each side. So I'm just going to go ahead and write what that looks like. That's going to be the cube root of all this big old fraction here. Cube root of x plus 5 divided by 3 equals, the cube root of a cube is going to cancel out. So this will just be left with y minus 1. And now I'm almost down to isolating that y. I just have to add 1 to both sides. And here you're going to make sure you put that 1 outside of the grouping symbol. So you're going to have the cube root of x plus 5 divided by 3, and then put your plus 1 on the outside of that, equals y. Okay, and then our final step is just to let us know, or let the reader know, that this is an inverse function. So we're going to change that y to f inverse of x. So it's going to be the cube root of x plus 5 to the power of 3 plus 1 equals f inverse of x. And that would be your inverse function. Remember, you can kind of check this algebraically. Those of y'all that found the pattern last semester, the same pattern still holds. Notice we started with the minus 5, we now have a plus 5. Started with the times 3, we now have a divided by 3. Started with the minus 1, we now have a plus 1. So that pattern still holds because we're still looking for the inverse. Okay, over here on number 4, it's going to be similar, but this time we're starting with a cube root function. So when we get down to those inverse operations, we're going to be cubing both sides. Okay. I'm going to give y'all a second to pause this and go ahead and try it for yourselves. Again, it's the same process. So go ahead and pause, and then I'm going to let y'all give it a try. Pause it now. All right, so for those of y'all that paused it, these would be the steps you should have taken. So the first thing you would have done is switched your x and y, which is what I've done here. Or sorry, that's replacing the f of x with y. Over here, I switched my x and y. Then I would isolate the grouping symbol by adding 3 to both sides. Okay, so that leaves you with x plus 3 equals 2 times the cube root of y plus 1. Then we would need to divide by 2, which is where that comes in, which leaves us with x plus 3 divided by 2 equals just the cube root, because these 2's would have canceled out, the cube root of y plus 1. And then to get from here to here, that's because we would have had to cube both sides. And again, you're just going to leave this messy fraction a messy fraction. So x plus 3 divided by 2 to the power of 3 equals now just y plus 1. And then to finish isolating that y, we would subtract 1 from both sides. And this would be our inverse function. Okay, so you should end up with x plus 3 divided by 2 all to the power of 3 minus 1 equals y inverse. Okay, and then last but not least, this I'm not going to be able to be super helpful because I don't really have a calculator. Not that I actually don't have a calculator. So next we're going to look at finding inverses graphically. So to find the inverse of a function graphically, you want to think primarily about, and I'm going to look at number 2 because that's the cubic stuff. You want to think primarily about the idea that it has to reflect across that line. Reflect across the line y equals x. Okay, and then another way to think about it is that the X and Y values switch. So if you're given a multiple choice situation like this, or even if you're not, I think the easiest thing to do is to graph the original function. So go ahead and take a moment to graph this in your calculator. Like I said, I don't have a graphing calculator at home. Well, I do, but the batteries are dead because it's got to be charged. F of x equals x plus 1 to the power of 3 minus 4. Graph that in your calculator and see what it looks like. Right, it should be a cubic function that is moved left 1 and down 4. So it should look 1, 2, 3, 4. Should look something like that. It actually looks a lot like letter A, okay? So letter A is actually our original function, which means that cannot be the inverse. Another thing to think about is this is a cubic function. So a cubic function is going to have an inverse that's a cube root function. So that eliminates both A and B because both of those are cubic. So this would be out as well. So we'd only be looking to see between C and D because both of those are cube root functions. So we want to see which of these cube root functions has that reflection across the line y equals x. To me, this is very confusing, so I'm just going to find some points and switch the x and y values. So for example, since I know that this is what your function is on your calculator, let's look at this middle point. The middle point there is -1, 1, 2, 3, -4. So we've got -1, -4. Let's find another good point. Looks like another good point is going to be 0, -3, and then -2, -5. So our inverse function should have the opposite of that. Our inverse function should have the points -4, -1, -3, 0, and -5, -2. So let's look at letter C and see if it has those points. So we got -4, 1, 2, 3, 4, -1, no, that's not there. Let's come over to letter D. -4, 1, 2, 3, 4, -1. Let's check the other points. -3, 0, 1, 2, 3, yep, that's there. And so is the -5, -2. So our inverse function is going to be letter D. Okay, I know that was a lot of info, but again, y'all have seen a lot of this before. And hope everybody's doing well. Still sleeping, sleeping, and sleeping. Maybe I'll join them soon. All right, hope you're doing good. Don't do anything I wouldn't do, and have a great weekend. Bye.